In this video, we're going to talk about how to narrow down the zeros, to find the zeros, and how many zeros should there be. The fundamental theorem of algebra is if f of x is a polynomial of degree n that's greater than 0, and a is a non-zero real number, then f of x has exactly n linear factors. Now, they may not all be rational, and they all may not all be real, but if the degree of the polynomial is n, then there are n factors. And n factors tells us there are n zeros. So the degree of the polynomial lets us know how many solutions there are to the equation. The complex conjugate theorem, if the polynomial function f of x has real coefficient and complex zero in the form of a plus bi, then its complex conjugate, a minus bi, will also be a zero. Complex roots always come in conjugate pairs. Have you noticed that when you solve the quadratic equation, there's the plus or minus, you'll get two answers. And so this is saying if there is one complex solution, then there is two complex solutions. Just because when you solve a quadratic equation, you always get two solutions. So not only do you know there's two solutions, you know they're related. That if one is a plus bi, the other one is a minus bi. And vice versa, if one's a minus bi, the other is a plus bi. So it's the same real number and the opposite imaginary number. So let's apply that. It says find a fourth degree polynomial with real coefficients that have zeros of -3, 2, and I, such that f of -2 is 100. So we want to find an f of x that has a 0 of -3, a 0 of 2, a 0 of I. But here, this is a complex or imaginary number, so it will have a pair. So they ask for a fourth degree. Here's 1, 2, 3, and then when we find its conjugate pair, we'll have 4. We'll have 4 zeros. So we have a 0 of -3, 2, and I, which tells us that x plus 3 is a factor, x minus 2 is a factor, and that I and -I are also factors. So x minus I and x plus I. But we don't normally have i's in our polynomials, so let's distribute this out and see what we really get. Recall that I squared is -1. Let's see how this cleans up. So we have x squared plus ix minus ix minus I squared. Now, on the complex numbers, these middle two terms will always add to 0. And I squared, remember, is -1. So we have minus -1. So this is x squared plus 1. That is the factor, and how we'll write that factor. So we have x minus 2 and x plus 3. We need to make sure we have the right compression or stretching, so we're going to put in an a, and then we're going to use this point that's given. If x is -2, y is 100. F of -2, 100. So I'm going to put 100 in for y, replace all the x's with -2, -2 minus 2, -2 squared, that's 4 plus 1. Here we have a times 1 times -4 times 5. That looks like a -20. 100 divided by -20. That would be a -5. So a equals -5. Now I can rewrite my polynomial right here, replacing the a with negative 5. Y equals negative 5 times x plus 3, x minus 2, and x squared plus 1. So here we have a 4th degree polynomial that has these zeros and goes through that point. Number 8, or example 8, or the next example. Find the 3rd degree polynomial with real coefficients at zeros of 5, negative 2i, and goes through 110. So, oh, I did it again. Here we go. Let me move up for you. I'll fold my paper. That's what I'll do. Okay. So a 3rd degree polynomial, and they give us 2 zeros. Ah, look at that one. It's imaginary. So it's going to have a partner. 5 is a 0, negative 2i is a 0, and our imaginary term becomes the opposite, so positive 2i. So this is 0 minus 2i, so this is 0 plus 2i, using that conjugate pair rule. 0 minus 2i and 0 plus 2i. That's going to give us factors of x minus 5, x plus 2i, and x minus 2i. And let's distribute this out to see what that would simplify to. Now we did learn that the middle terms always add up to 0, so that's plus 2ix and minus 2ix. This time I'm not going to write them, but I will multiply the, I'm going to have positive times a negative, so it's going to be negative, and 2 times 2 is 4i squared. This is a negative 1, then the minus, that's going to end up being a plus 4. So x squared plus 4 times x minus 5. Just bringing that guy down. Okay. They also told us that this point, or this function, goes through, I guess f of x instead of y. We could write f of x or y here. This goes through 110. So the y value of 10, x value of 1, just replace all the x's with 1. So we get 1 minus 5, that is negative 4 times 5. It's negative 20. 10 over negative 20, a equals negative 1/2. Okay, so now I know my a, I can plug that in. F of x equals negative 1/2 times x minus 5 times x squared plus 4.